So here we are, chapter 4, 4.1a, and the name of this chapter is Systems of Linear Equations in Two Variables. So we have been doing some things in two variables. We have been graphing things like 3x minus 2y equals 6, and we would put this in the form y equals mx plus b and be able to graph that. We are also able to make a table, put a number in for x, and see if we put a 0 in for x, what y would end up being to make that true. So we've done a lot of different ways to figure out how to graph a line and how to solve for the x and the y. This particular chapter, it says in systems of linear equations in two variables. Systems basically means that we're going to have two or more lines on the graph. And in order to have two or more lines on the graph, we have to have two or more equations because each equation represents one of the lines. So when we have two lines on the graph, we have three different options for how those lines are going to relate to each other. The first one, and the most common one, is they're going to cross. And when two lines cross, they always cross at one point. So we have one point that is common to both the red line and the blue line. So let's say it's 3, 2. Let's say that that is where those two lines cross. Well, that means that if we have an equation here and our red equation here where they cross, that those 2 points, this x value and that y value, when we plug them into the equation, they're going to work. They're going to work for both the blue equation and the red one. So let me give you a little bit more detail on that. So if we had this equation in that equation, and let's say that the top equation is going to be a red line, and let's make it look like that. The bottom equation is going to look like that. So they cross at one point, and let's say that that point is 4, 3. That means that 4, 3, the x value of 4, the y value of 3, will work for this equation, and it will also work for that one because it's common. So let me show you. So 3 times 4 minus 3, 2 times 3 equals 6. So I just put in 4, 3 into that top equation. 6 equals 6. So those values for x and y work. Let's put those values for x and y in the bottom equation. So 8 plus 12, does that equal 20? Yes, it does. So see what happened there is that the x and y value, 4, 3, where they cross, where the lines cross, that's what they have in common. So that means that this point, these numbers, will work in both of these equations because that's what they have in common. All the other points along this red line here will only work for the top equation. All the points in this blue line here will only work in the bottom equation. The only one that works in both equations is where they cross. So all that to say, that is one of your options when you're figuring these out, is two lines are going to cross. The other option is that the lines don't cross at all. They're parallel. There's no solution to this because the only solution is where they cross. And then our third one is not only where they cross at one point, but your other option is that the blue and the red line lie on each other. Therefore, all of the points work because they're basically the same line. So you either get one solution no solutions, or an infinite number of solutions here. So how do we figure out what our x and our y's are? Well, one of the ways that we can figure it out is to just graph it. So example 1, bottom of page 322, gives you that equation and that equation. And what they want you to do is solve for x and y. They're interested in where those two lines cross. So you can do this method here for the top equation and get enough points here that you can draw the line. And then you graph this one and draw the line, and where they cross, that is the x value and the y. The problem is, what is the x value and y value? So for instance, if it crosses right here, what is that point? It looks like it might be 1, 2, 3 over and 2 up, but what if it was a fraction? It really makes it hard when you're showing a graph. You can kind of get an estimate of where the things cross, but you can't be exact. So we're going to show you a couple different ways to do this. Now, in old books, this was called the elimination method. In this book, for some reason, they've changed it and they call it the addition method. So what you do, well, they kind of start out, I think, pretty goofy here with some that are a little bit more tricky than I want to start with. So let's do some from, I was going to say from the homework, but the homework doesn't look like it's that much better. So for instance, x minus y equals 6. Okay, we're going to move this one out of the way for right now and look at a different one. And x plus y equals 3. So if I wanted to solve for x and y using the addition method, I draw a line, give myself a plus sign, and I add like terms. So I'm going to add x and x and get 2x. I'm going to add negative y plus y and get 0. So I don't even have to show that because it's 0. And that equals 6 plus 3 is 9. Then I'm going to divide both sides, and I get x equals 9 over 2. So that's my x value that makes both of these work. That's the place where I cross, is where x is 9/2, but I haven't found the y yet. Now I'm going to have to take one of these equations. Let's just take the top one. Oops, sorry about that. And instead of putting x in there, I'm going to put 9/2 minus y equals 6. So I need to get rid of that 9/2, so I'm going to subtract 9/2 from both sides. Problem when you make up these problems is you end up with fractions usually. All right, let me do this right. So I'm going to subtract 9/2 from both sides. Okay, so that goes away. Negative y equals 6 minus 9/2. And I'm going to figure that out and find out what y is. So if I get y equals some answer, I'm not figuring it out right now. Let's say I get y equals 3. That means that these two equations, let me get them back up here. These two equations here have an x value of 9/2 and a y value of, what did I say down here? If I made it up, y is 3. That means where these two lines cross, the line for this and the line for this, is at 9/2 3. That point right there is 9/2 3. So that's what we're doing. Problem is, some of these are not as simple to figure out, And that's where we run into the one I have over here that's left on the screen. Because sometimes you can't just add the x's and the y's and have one disappear. And that's our goal, is to get rid of either the x's or the y's so that we're only doing one variable at a time. So what we end up having to do is finagle these problems around a little bit so that they do cancel when we add them together. So for example, if I want to add, let's say, the 3y and the y, let's say I want these two, when I add them together, to be 0. In order for that to happen, this number down here, let me put it in red, has to be a -3, right? So that when I add 3 to -3, the y's disappear. So how do I get that to be a -3? Okay, here's the way you do it. You find out what you want this number to be in front of the y, and you multiply the entire problem by that number, and that will give you your -3. Now there's some other tweaks that go on later, but let's just look at this one for right now. So the top one stays the same. We don't need it to change. The bottom one, if we multiply that -3 times 2, we get -6x. There's our -3y. And -3 times 4 is -12. So we just made the problem, it's the same problem, we just made it kind of bigger. It's kind of like taking 1/2 and changing it to 3/6. It's still 1/2, it's just now it's not reduced. And that's what we did. We did kind of this anti-reducing. So instead of factoring out a -3 and getting this, we put the -3 back in to get this. All right, so now let's add these. This gives me -2x. These go away, and that equals -2. Exactly what I wanted. Got rid of one of the variables. Now we can solve for x. So x equals 1. Now we're going to take either one of these equations here, doesn't matter. Let's take the top one, and we're going to put the 1 in for the x so that we can find the y value. Subtract 4 from both sides. Divide by 3, divide by 3, and we get y equals 2. So x equals 1, y equals 2. That means that if we were to graph this, that means at x is 1, y is 2. At this point right here, this line and this line cross each other. So that's what we found. So if we had a graph there and a graph here, that's what they have in common with each other, is that point right there. Okay, well, let's go on with this, and then we'll be done with lesson 4.1. So I've got a few examples to go yet. Well, quite a few, it looks like. So I'm going to go ahead and start the next video.